All right, here we go. Stats 6.2 block 2. So we already learned about t distributions versus z distributions. To remind you, a t distribution is very similar to a z with fatter tails, right? So as the number goes up, so as the number in your sample goes up, a t starts to look a lot more like a z until you get to 30, and then a t is exactly like a z. So what we're going to do today is, instead of giving you the data, we're going to, or instead of giving you the mean, the standard deviation, all that good stuff, we're actually going to give you the data and you have to enter it into the calculator. It's actually easier. So first thing, we got 10 sports cars. We're looking at a 95% confidence interval. So the first thing you have to do is, when you go stat, go to edit, you got to enter all of your stuff. So I entered all my stuff for problem number 1 in list 1, and I entered everything else for problem number 2 into list 2, right? So now what I need to do is, step 1, always do one variable stats first. That's the first thing you want to do, because that will preload all of the good information into my calculator for me. So I go stat, go over to calculate one variable stats. I want to do it on list 1, so I hit second one, calculate. It'll give me a mean of 21.2, a standard deviation of 5.69, and a population standard deviation of 5.4, right? So now if we want to construct the interval, we can do what I showed you before, or since this is data, we can go stat, we can go over to test, and we can use number 8, a t-interval. And remember, we're using a t-interval because, first of all, we don't know the population standard deviation. The population didn't say anything about it being normally distributed, and my n is under 30, so I have to use a t-interval, right? So I go t-interval. So it'll say, do you want to use data, or do you want to use your stats? So I'm going to go data, because that's what I entered in here, right? What list do you want to use? So I'm going to use list 1, second one. Frequency should be 1. And what's your confidence level? So I want my confidence level to be 0.95, right? Notice if I go stat, real quick, it was all entered in for me, right? So I guess I could have done stat too, or I can do data. Since I did one variable statistics first, it uploaded all of the data into my inputs for x bar, sx, and standard deviation, and n. So if you look here, it tells me what the mean is, it tells me what the standard deviation is, it tells me what the n is. So this has 9 degrees of freedom, and it gives me the interval. So I'm just going to go ahead and draw that for you real quick. Right, so it's going to be kind of a normal-ish looking distribution. The mean is going to be 21.2. The standard deviation is going to be 5.69, and the high and low bounds are going to be 17.128 and 25.275. And technically this will be divided by the square root of n, which is 10. Last thing, remember, the margin of error is the distance between here and here. So if the question asks you to find the margin of error, all you have to do is take a top or a bottom, 25.275 minus 21.2, and that'll give you the margin of error. So this distance here is 4.075. That's from your middle to the upper fence post or to the bottom fence post. Cool. Example 2. So the first thing I want to do is I want to figure out, let's interpret this real quick. So we're 95% confident that the true mean of sports car miles per gallon is somewhere between 17.1 miles per gallon and 25.27 miles per gallon. Example number 2. So we have ACT scores now, and we're going to construct an 80% confidence interval. So the first thing I need to do is I need to figure out, am I using a z-curve or am I using a t-curve? So it didn't say anything about a normal distribution, right? So I know I need a lot of data. So when I look at this stuff, it looks like I have 12 data points here. So that's not going to be big enough to use a z-curve. So again, we're going to use a t-distribution. So the weird thing about this is that it's in the stem plot format where it says 3/4 is 34. So this is actually 9 on the SAT, 12, 15, 18, right? So when I go and type that stuff in, go to edit, I typed it into list 2, right? It's all there in list 2. So now the first thing I do, remember my last example, is I go stat, calc, one variable statistics, but I want to do it for list 2 now because I typed in list 2. Enter, so I get an X bar and that gives me all that good stuff. So now when I go and I go stat, test, and I use number 8, a t interval. It doesn't matter what you look at, everything is pre-programmed in there for you. The only thing I need to change is this right here. I need to make it 0.0. There's point, that would be an 8% confidence interval. I want to be 80% confident. Boom. So stat, test, t interval, that's all good. Or I could just hit data, right? So I get my X bar, again, I'll just draw this out for you so you can see what's going on here, right? This is gonna look more normal than this one because n's bigger, but still not quite normal because n's not 30. So 22.9 will go in the middle. The standard deviation is gonna be 7.9 divided by the square root of 12. And then the high fence post and low fence posts are gonna be 19.8 and 26.02. So I'm 80% confident that the true ACT mean is between 19.8 and 26.2. Now some of you are like, well, that's really, really far. And the reason why is because we're using an 80% confidence interval, right? So, and also our n is very, very small. Very small with a big standard deviation. Let's figure out what the margin of error is real quick. The margin of error is going to be this minus this. So if I do 26.02 minus 22.9, the margin of error will be 3.12. Right? So you can kind of work backwards to find out what the margin of error is and all that good stuff. All right, let me know if you have any questions. Peace.